Okay, so thank you for joining me. I'm very happy to be here. But before I'm starting, I want to start with a quiz. It will help us to get into the session that I'm going to talk about. So scream at your screen, what do you see right now? If you screamed Apple logo, you're right. If you screamed a gray apple with a bite on the right side, you are right. But again, it's Apple, of course. Scream, what is this? If you said Chrome logo, great, you are on. If you said 3 nines with different colors, you can say that you can see something like that, but it's the Chrome logo. Now, the third question, what is missing here? If you screamed the BMW logo, you're right. But this brings me to the topic of today. Why is that? Because once you look at the front of any BMW, the design is mostly the same. So we are recognizing the BMW by its design. So I don't need the BMW logo to say, yeah, this is a BMW car. And that brings me to the idea of branding, and branding help you to distinguish your product from other products. And that brings me to design systems, which is the topic of today. Design systems help you to distinguish your product from other products. But not only that, of course, and we will drill down to what are design systems, how design systems can help you from a perspective of development, not from the design itself. But we'll learn that later on, and how they relate to component libraries. So with that, a little bit about myself. If you don't know me, I'm Gil Fink. I'm Sparks's CEO. I'm a senior consultant. I work in the industry for 20 years already. I'm a GDE, Google Developer Expert in web technologies for, I think, 4 years, something like that, or even 5. And I even wrote a book in the past in 2014 called Pro Single Page Application Development that explained how to develop single page applications with Backbone and ASP.NET. That was 9 years ago, and the book is still selling, not a lot of sales, but it's still relevant with all the ideas behind how you can create single page applications. So what we're going to do in this talk, first of all, I'm going to talk about design system and why you as a developer should care about that topic. Then we'll talk about the relations between designers and developers. Last but not least, I'm going to talk about how we can develop component libraries using stencil and storybook. So wait with me and bear with me, and we'll get to that point at something like half of the talk today. So design systems. What is a design system? So a design system is a common set of rules and constraints and principles and best practices that's implemented into some design in your company. What I mean by that, you identify a lot of things that are commonly used or you want to apply to your applications, and then you apply those things in a common way. Let's talk about what are those things. So the core components of a design system includes colors. You saw Google red, yellow, green colors in Google logo. In Filestack, you have the gray and red colors that are the main colors that the Filestack uses. Other than colors, we have iconography. Iconography is the icons that you are going to use as part of your design system. Icons that identify some parts, regular parts or icons that people are waiting for. For example, an email icon or a text icon or play icon, which are specific to your brand or your company. Elevation, how elements are stacked on top of other elements. Mainly you will create that with blur or shadow, box shadow, things like that in your implementation. But in design perspective, how you put elements on top of other elements and how you make the elevation work is something that the designers are very fond of and use a lot. Copy, not copying something, but rather how you can copy different components or different items inside your design or your components, that you have the same user experience in different items in your application. So how do you do that? How do you make those copies, things that the UI and the UX look a little bit the same, but the functionality works differently? How you create typography, how you use fonts, which fonts are you're going to use in your application, and what are the font sizes and how they scale in your screens. Animation, how animation works in your application. Is it is-in, is-out animations, or well, why not is-in and out animation, or any reserve curve animation, things like that, and the timing of each and every animation. The layout, it's a core component that we as developers see a lot, how you lay out components inside your web page. And of course, illustration, how you illustrate something that will be very understandable by your users, so they will know what is going on in front of them using illustrations. So these are the core components of a design system. But why should we have design system? If you remember the BMW, the idea is branding. You create your own brand and you are identified by the colors, the typography, the icons, the fonts, and everything else inside your design system. And whenever you do that, you distinguish your products or web applications from other web applications that do not have design systems. You also apply the same UX, user experience principles, on your consuming application. Okay, each and every application that you're creating look the same and act the same. So it is very easy for users to get into your application and start working with it if you have the same UX principles. And we will talk about reusable shared component layer later on. So as I said, design systems, this comes from designers' perspective, but most of us are developers. How this relates to us in the world? So, you know, in the real world, you are not sitting in your cubicle alone. You have designers in your company. And designers and developers work very well with each other. I can tell you horror stories about things that I was asked to develop as a developer, with some rare and bizarre designs with a lot of circles and things like that. And sometimes it is very hard to talk with the designers to make them understand that what they want is something that is achievable, but it will cost a lot of development time and effort for this particular animation or this particular design. So one of the things that I'm doing lately in companies that I'm consulting for is being the mediator between development teams and designer teams. And I'm trying to fill the gap between those teams. Now, what we're doing is mainly we start with common language. The common language which I'm using a lot is atomic design. If you haven't heard about atomic design, it's a book which is online and you can go to it. It's free online. It was written by Brad Frost, and it is a lot of principles how to create design systems and using the atomic design. What is the atomic design? Take some chemistry um, knowledge and talk with both developers and designers in that same common language. How we do that? We have 5 different moving parts in atomic design, which are atoms, molecules, organisms, templates, and pages. So let's drill down and understand each and every part of the atomic design. We're starting with atoms. An atom, like in chemistry, is the smallest part of your design. What is the smallest part? Because everything is created with atoms in nature, in chemistry, then in design, the atoms are the smallest components which has some small behavior. For example, a label, an HTML label, or an input, which is an atom for inserting some, characters and work with that, or even a button, or checkbox, or radio button, and things like that. These are the atoms. Now, whenever you are talking with a designer and you will say, I want to, you ask me to develop a molecule is combining 2, 3, 4, 5 atoms into one small part with a behavior. Okay, for example, if we're looking at this screen, now you have a label called search the site, an input to enter some characters, to type some characters, and of course a button. And the button, when you press this button, you're going to do a search in the site. That means that I created a molecule for site searching. Now, what else can we do with the hierarchy of the atomic design? We can develop organisms. An organism is a bunch of molecules and atoms that are combined together to create a behavior like what you see here in the screen, a header. A header includes some image, some menu, and some search area. And this is an organism, which is, organisms can be a header, footer, the main content of the web page, a menu in the web page, either on the left or the right or whatever. So if a designer says that he created an organism, this is a couple of atoms and molecules combined together to create a behavior. Now let's move from chemistry and let's talk about what are the 2 other parts of the atomic design. One is templates. A template is just how some area in the screen or the entire page will look like without the content of that page or that area. That means that template by itself only declare how things might look like, but in order to create those things, you need to create their instance, which is pages. A page is an instance of a template that includes all the content inside of it. So now we have a common language with the designers, and we can speak about or talk about things, and they might, okay, I will say might understand what we are talking about. For example, I want to talk about a search area, which is a molecule. So let's talk about that molecule, which is created through 3 different atoms. Okay, so we have a common language. Now, how do developers expose that language for us, the design system? They use designer tools like Figma, InVision, Photoshop, and more. And all of those designer tools exposes to us how the look and feel of components inside our web page or inside our application will look like. In some of them, we can take the CSS or we can take the content. There are tools that can help you to create the design system as some guidance inside of them. but I'm not going to sell designer tools for you. So let's move from design to development, because most of us are developers. So we understand now what is a design system, how to talk with the designers, but then we want to take the design system into development. How can we do that? So this is where components libraries comes into place. A lot of companies will create the design system parts as part of some component library. And that component library will be the standard to determine how components will behave and configured and how they should be used by the users or even other developers that want to use those component libraries, of course. So the question is how to build a component library on top of a design system. How can I do that? So there are a lot of answers. You can do it with React, Angular, or any framework out there. But what I'm suggesting to do is whenever you have a design system inside your company, inside your organization, think about Web Component API. What is the Web Component API? It's a standard that was released around 2014, something like that, the first bits and bytes. And it's a mature web standard that is implemented and supported in all the browsers. The idea of Web Component API is it's a native ability to create components that can be used inside your application, even in Angular, React, Vue, whatever framework that you want to use. So each and every web framework can use Web Component API components. Okay, so because of that, web components that are created using Web Component API are suitable for building design systems. Why is that? Why is that? Is because you can consume them in every framework and every in library out there, and that's cool because if you're creating your component library for the design system in React, you're coupled to React. But if other team in your company uses Angular, for example, you will have to do a little bit of tweaking in order to use the Angular part. So how do you create the Web Component API or a component library with the Web Component API? I'm not suggesting to use the raw API. What I'm using mostly is Stencil. Stencil is a web components compiler. You're writing the web components with modern technologies like TypeScript and JSX in the format that the compiler expects. And the compiler is going to generate for you custom elements, which is one of the APIs that are part of the Web Component API. I haven't mentioned the APIs, but it includes 4 different moving parts: templates, ES modules, Shadow DOM, and custom elements. This is not a topic about Web Component API, but if you want to learn more about it, you will find a lot of content in the web about the APIs. So what is Stencil? As I said, it's a compiler that compiles the code that you write into web components. Let's see it in action. Now, before I'm starting, I already did npm init stencil, which is the command in the command line that you're going to use in order to create a stencil component library. And I did it because I don't want to get stuck with all the npm installations and things like that. I wanted to show you how you can use that API later on. So what we're going to do is we're going to develop a component library for our design system. And that component library is Dino components. We have in the design system that we're creating the idea of having dinosaurs as icons and things like that in our system. Why? Because I like dinosaurs. So this is the started project of a component library of that will be generated for you whenever you do npm init stencil. Okay, I haven't done anything except from installing, did npm install for all the node modules that we need. Now, as part of stencil, what you gain is you have a generator for components. So I can write npm run generate, and then I can generate my component with the command line. So what is going to be the component tag name? Let's write Dino button. And I can add and remove things like style sheet, spec test, and end-to-end test. Let's remove the end-to-end test and the spec test. I just want to generate the component and its style sheet. So I can press enter, and voila, I got generated in my project the Dino button, only a stub for the component, of course. So let's create that component. Here it is. Not a lot of code. In Stencil, you generate components using a decorator called component, add component. You say that the tag is going to be what HTML tag you want to be generated. It's going to be Dino-button. It's important to have at least one dash because it's something in the specification of the Web Components API. The component is going to be wired to the Dino button CSS file that was also generated. And whenever you say shadow true, it means that you will gain the shadow DOM implementation and inside your component. Now, when you create a component, it's just a JavaScript class. Inside the class, you can have props, which are the attributes that the component is going to get from the outside, meaning that I will have an attribute called text and an attribute called btn clicked, which is going to be an event handler that I'm going to use in order to raise the event of button click. Now, as I said, we're using TypeScript here. This is why we have decorators, and we are using JSX. If you're not familiar with JSX, it's the HTML in JavaScript part of React, and in other frameworks it became very popular as well. So you can see here a render function, what is going to be rendered by the component, and what it returns is an anchor with the role of button because we want accessibility on click that will use the button click that we got from the outside. Some SVG, we'll see later on what is this SVG is going to be, what it's going to generate. And we have a span with the text that we got from the outside. Now let's make the component more fancy. And here are some styling that I'm using. Probably got it from my designer in a company, and they said you need to have a border with this this color, and the color of the font is going to be this color, and the size of the font is going to be 19 pixels, and etc. And I'm getting the layout of how I put the SVG icon in the button from the designer, and that's it. Now, because we are in a Filestack conference, let's generate another component, npm run generate, and let's call it Dino Filestack. And again, I don't want to have spec, and I don't want to have E2E test, and let's generate, oh, I generated the E2E test, never mind. Now we have the Dino Filestack here, and let's implement it. What is the Dino Filestack? The Dino Filestack is a component that we're going to use in order to use the Filestack client. Okay, this is important from Filestack library. And in the constructor of the component, we're going to init the client with the API key that we have. And then whenever somebody clicks on our Dino button, our fancy Dino button, it is going to open the Filestack picker. That's it. Now, if we want to use both of the components, we can go to the index.html file that we got from Stencil out of the box. We can do something like this. Here is me using the custom element of Dino button. That element will be generated for us by Stencil compiler. It's going to get the text, click me. I'm going to use also the Dino Filestack component. And when the application, when this HTML will be loaded, I'm going to select the Dino button and wire it to the btn click prop. Let's not write to the console. Let's do something bizarre. Use the alert. Okay. So I'm going to alert Dino button clicked. Now I can do something like npm run start and start my project, my development server. And when it is loaded, let's see the fancy Dino button that we have. And now, so we have a Dino button. You can see that it has the T-Rex icon. This is the SVG that I used. Whenever I click it, Dino button clicked alert. Whenever I click the open file picker, voila, we have the Filestack picker and we can use it. Cool. Now, let's move on. We created a component library, but, and this is a big but, we have a problem here. I don't want to use an HTML file and to put inside that HTML file all my components. I want to test them in lab environment. How can I do that? This is where Storybook comes into place. What is Storybook? So Storybook is a tool that enables you to create, to get user interface development environment that can help you to visualize a lot the states of the components that you are creating inside the lab environment. How do you do that? First of all, in every project that you have, you might be able to use Storybook. How do you do that? npx sb init. If Storybook CLI identify the framework that you're using, if it's React or Angular or even Stencil, then Storybook will know how to generate its environment runtime. Okay, but if you want to be specific, you can do npx sb init with the flag type and give it HTML because we are creating a Stencil component library. Then Stencil component library use the HTML type visualization. Out of the box, as I said, there are plugins in Storybook for Angular and React and for other frameworks as well. Of course, Vue, if you're coming from that background. Now, after you run the SB init, it will generate a lot of things for you out of the box. And you will be able to run the Storybook web server using the command npm run storybook. What can you do later on? And we'll see the demo in a second. You can write stories. A story is the visual test for your component. It will get the component as a parameter, and then it will display it, and you will be able to play with the component and the component's properties inside the lab environment and see the states of the components and how they change the component in lab environment. So with that, let's go on and let's take the component library that we built and let's wire it to it storybook. Now, it will take something like 9 to 10 minutes when you run the npx SB init. And I don't want you to wait for that. So let's jump into our solution after I ran the npx SB init. Okay, what is going to happen is you get a lot of things out of storybook. For example, a lot of stories, example stories that you can use to see how you write stories in storybook. More than that, you have the storybook configuration. We will go to that configuration in a second. Last but not least, inside the package JSON, you have new commands that will be generated by storybook. One is to create the development server, or to run the developer's development server, the storybook development server on port 6006. The other one is going to build storybook. Bear with me about that. We'll talk about it later on, why to use build storybook. Now, I only did npx SB init. I want to wire storybook to my component library, my stencil component library. How do I do that? First of all, I'm going to run npm run build. Why I'm doing that? I'm doing that because stencil will generate a folder called loader that I will be able to use later on by storybook to load my components. Okay, so I'm letting stencil generate for me the loader, and then I'm going to the preview.js file, and I'm going to write the following code. Import define custom elements from loader that is going to be generated for us in a second, and just run define custom elements. That's it. This is the wiring of storybook to stencil. Okay, easy peasy. Now, as you can see, I'm not seeing that. Let's do this. I'm still not seeing the generated loader folder, even though it looks like it was generated for me. Now, let's say up until it will pop up, implement the stories for Dino button and for Dino Filestack. So how do you do that? Let's create a new file, TypeScript file, and let's call it Dino button dot stories. This is the convention, and enter. Now, here is the story for the Dino button. I'm creating the story title. Under component, it's going to create a Dino button entry. I'm creating a template how I'm going to use my component. As you can see, Dino button, just use the custom element and text equals args, and we get the text from the outside. And we have the generation of the template to create an instance of Dino button. Later on, we wire to that Dino button the arguments. That's it. That's the story. That's the whole story. And now, if I want to create another story, this time for the Filestack, just a moment. It was stuck a little bit. So I can do something like Dino Filestack dot stories, and this is the Dino Filestack story itself. No arguments. It's not getting any properties from the outside and nothing else. Okay. And that's it. Now, hopefully, I don't see the loader that was generated for me. That's strange. Hopefully, if I'm right and did everything as expected, whenever I run npm run storybook, it is supposed to run the stories that I created and show you them inside the storybook environment. Let's wait for storybook to start. And it's taking some long time. I don't know why. Maybe because I'm also presenting. Okay, too long, but you can see it's running. Yay. So what the storybook is going to do is load the storybook development server and open a website. Then we will use that website to go and look at the components that we created, as I said, in lab environment. Now, hopefully it will happen in our lifetime, because it's taking too long to load, unfortunately, for me and for you as well. But once it will open on port 6006, I will be able to play with the lab that Storybooks exposed for me, and we will be able to see the components that we created. Okay, too long. Here is the loader. Like, it popped up. It took a lot of time, unfortunately, to pop up. So we're still waiting. And you should ask yourself, okay, we saw stencil to generate the component library. We're using Web Component API. We're using Storybook as lab environment, but why, except from having a lab environment, why should I use Storybook? Keep that question in mind. Here is a Storybook environment. It was loaded. You can see in the canvas the component. You can see that whenever I'm creating arguments, then I can play with the arguments. You can see that the code, the text here is changing. Okay, cool. I can go to a different story, the Filestack story, and use the implementation and see how it works as well. And I can even go to the docs tab if I'm a developer and see the definition of, or the documentation of the component, and even the code that is being used in order to generate this component. Now you can talk about it with other developers, and if you have the junior developers, you can send them to play with the components that they are creating and show them the code and how to use the components. And this is very cool. What else? As I said, Storybook can help you to visualize your component in lab environment. But we talked about designers and design systems beforehand, how it relates, or what can we do with that. So you can generate a website using the build the storybook command, and then you can take that website and put it on a server. And then you can send the link to the server to your designers in your company and ask them to do visual testing on the component that you created, which is a very cool thing to do. This is something that we did in a few companies. We created a storybook out of the storybook lab environment out of a component library. Then we send the link to the production storybook to the designers, and we could have talked with them and reasoned about the things that we did. and see the changes and the animation and everything inside a lab environment. And that's cool. It also helped to expose junior developers or developers that comes into your company to the API that you created, or even how to write the components or use the components from the component library. So what next? Wrap it and publish it. Take the component library and package it inside your package manager, either NPM, Node Package Manager, or Artifactory, or any other package management system that you are having in your company. You can deploy the storybook build to a server and expose that server to your UX team, and of course, add more components to make your component library rich. And if you want, you can create it an open source component library, which you can use later on. So building a design system is a necessity for any company. And creating the component library can help you achieve your design system goals. With that, I want to thank you. If you want to follow me, I'm at Gil Fink in Twitter. And if you have any questions, I will be happy to answer.
Hi, Gil. So we've gathered these questions. Okay, here they are. So first, why should we use Web Components APIs to build the design system components?
So as I said in my talk, whenever we are creating component libraries with the Web Component API, we can expose those component libraries and consume them by any other framework in our company. If the company has different stacks of front-end development tools, for example, React, Angular, Vue, whatever, then they will be able to consume the component library, which, as I said in my talk, mostly will include the design system component that exposes the functionality, the common user experience functionality that we want to achieve in our company.
All right, thanks. Okay, so the next one is related to the statement that you made earlier that design systems are a necessity to businesses. So how can a design system help reduce development time and cost?
So it's not going to help you decrease the the development time and cost, but rather it will help you to, if you're creating a design system and you create a component library, then if you have a shared component layer, that component library, for as I said, then you're going to not to create in every application in your company the same component over and over again, because you created one component that can be reused in each and every application. By that, you are going to decrease the amount of development, and this is not related to design system, but rather to a shared component layer or shared component library that you're creating in your application. But whenever you create this shared component layer, most of the time, it will expose the design system that you want to create in your company. That's it.
Okay, thank you. Next, what are the benefits of using a design system for scaling applications?
Okay, so design systems are not going to scale the application, but rather scale your users. What I mean by that is whenever a user is going to use the 2 or 3 applications from the same company, and the company has a design system, the same UX principles will be applied in each and every application. So the barrier to get started with the application will be lower, and users will understand how to use those applications faster. That means that users, if they, of course, love how the application look like, can help you gain more users. It's not going to scale your application, but rather scale the users.
All right, thanks for that clear explanation. So the next one is, it actually depends on your opinion. So it says, is integrating a ready-made solution better than creating a custom one?
Okay, that's a tricky question because a lot of companies today uses some sort of a design system. For example, a baked design system. For example, in the world of React, which this is something that I'm doing a lot of developers use material design or material UI component library that exposes material design, which is the design that Google uses. So they don't have their own brand, but rather they are helping to spread Google's brand. Saying that, because they have the component library, for example, that material UI component library, they are building applications faster because they have a tool to build faster web pages and applications. Whether should us use or create our own design system, our own custom implementation, it depends on how much we want to invest in our product. Okay, a design system is something that is costly. You need a designer, you need a dedicated developer or developer team to create the design system and to spread it. And the cost is I won't say it's very high, but it is costly on one hand, but the gain is branding and making your brand shine, or making your brand look or distinguish your brand from other companies that uses material UI. I'm not saying it's bad to use material UI, but we're all using material UI. In the past, we used Bootstrap or Tailwind or things like that. You always recognize those styles from those component libraries and these design libraries, but they have their own style. It's related to a company, if it's material UI, or related to some style that a developer created for you as a convention, for example, Tailwind or Bootstrap or Foundation or whatever, any the CSS styling framework that you're using. So it's, you need to think about it, whether I want to create my own custom implementation, spend a lot of money, but create my own brand, or use some baked implementation that forces me for conventions and things that are something that our designers in the company might not want to use. Okay, so it's a scale. You need to figure out by your own. I won't say go to this or go to that implementation. It depends on the company. It should be reasoned about, and that's my answer. It depends.
All right. Thank you for the great answer. I hope that will be sufficient for our audience here. And thank you for the presentation, Gil.
Thank you for hosting me, and thank you for this great conference.